Hello everyone, this is the part 3 of Unit 6. In this video, we will study about different approaches for concurrency control. They are locks, timestamp ordering concurrency control and optimistic concurrency control. At first, locks. Locks are held locally and cannot be released until all servers involved in a transaction have committed or aborted. When locking is used for concurrency control, the objects remain locked and are unavailable for other transactions during the atomic commit protocol. Since lock managers work independently, deadlocks are very likely. Let us consider the following interleaving of transactions T and U at servers X and Y. In this figure, transaction T locks object A at server X and transaction U locks object B at server Y. After some time, transaction T tries to access object B at server Y and waits for U, as transaction U is using object B at server Y. Similarly, transaction U tries to access object A at server X and waits for T, as transaction T is using object A at server X. Here, we have T before U in one server and U before T in another server. These different orderings will occur deadlock, and this is the example of cyclic dependencies. The second one is timestamp ordering concurrency control. In timestamp ordering, each coordinator issues globally unique transaction timestamp. A timestamp consists of local timestamp, server ID. This timestamp is passed to the coordinator of server involved in the transaction. To achieve the same ordering at all the servers, the coordinator must agree as to ordering of their timestamp. Each server accessed shared object according to the timestamp. Now, optimistic concurrency control. In optimistic concurrency control, each transaction is validated before it is allowed to commit. Transaction numbers are assigned at the start of validation and transactions are serialized according to the order of the transaction numbers. Let us consider the following interleaving of transactions T and U, which access objects A and B at servers X and Y, respectively. The transactions access the objects in the order T before U at server X and in the order U before T at server Y. Now, suppose that T and U start validation at about the same time, but server X validates T first and server Y validates U first. The validation protocol makes a rule that only one transaction may perform validation and update phases at a time. So, each server would be unable to validate the other transaction until the first one has completed. Here, deadlock will occur, and this is an example of commitment deadlock. In next video, we will study about distributed deadlocks and deadlocks prevention.